get x squared minus x minus 2 equals 0, which is way more human. And I can easily factor it into x minus 2x plus 1 and get x equals 2 and x equals negative 1. These are the critical numbers. 2 is right here, of course, and negative 1 is right here. And now I have to find the sign. So the 12 in front did not change anything, right? So I will plug in a number to the left of negative 1, like negative 10. Negative 10, negative 10. What is the sign of this product? Negative, exactly. Let's plug in 0, which is very easy to plug it in this.
Negative 24.
Perfect. And let's plug in 10. 10 minus 2, 10 plus 1. Now I have to determine this value, and I have to determine this value. But I have the function in the graphing calculator already. I'm just going to go to second and table and punch in negative 1 and 2. So it's 19 and negative 35 respectively. 19 and negative 35. I'm sorry, I don't know what happens. I don't know where the volume is. If you can tell me, it just disappeared from here. I always turn it off, but where is the volume button? I have to go into some settings, right?
Should be the bottom right corner.
Yeah, it's not. Sorry about that. Okay, so now we have to make sure that these two rows work well together, correct? Perfect, let's try. From negative infinity to 0, the function,
Increases.
is that correct?
Yeah.
From 0 to 19, the function is?
Increases.
Good. Is that correct?
Yeah.
Supported by the sign. From 19 to 5,
Decreases.
is that supported by the sign?
Yeah.
Good. From 5 to 0,
Decreases.
is that supported by the first derivative?
Yes.
From 0 to negative 35,
Decrease.
is that correct? Supported by negative 35 to 0?
Increases.
Correct. And from 0 to infinity?
Increases.
Perfect. It seems that everything is working well. Now I need to identify this point. Negative 1, comma 19. What kind of point is that?
It's an inflection point.
Now, we did not get to the second derivative yet. It's a local max because it's positive, 0, and then negative. What type of point is 2, comma negative 35?
Local min.
Yes, it's a local min because of the signs of the derivative change from negative to positive. Now we're ready to determine the second derivative. Second derivative, y double prime is 24x minus 12. So the second derivative set equal to 0, 24x equals negative, equals positive 12, x equals 1/2. So, of course, I have no room. So I have to insert 1/2 right in here. And this will be 0. Let's study the sign directly, because I need the sign left and right. So please plug in any number to the left-hand side of 1/2, like 0. The sign.
Negative.
Perfect. Which means the function will open downward. Please plug in any number to the right of 1/2, like 100.
Positive.
So then the function will open upward. What kind of point will this be? But I haven't determined the y coordinate yet. So I have to plug in 0.5 first. Back to the function. I plug in 0.5. Negative 8. So when you redo this problem, I hope you're going to redo this problem that you're going to make some room between 0.2 and 2, 0.2 and 2, so you can insert this, and of course between 0 and negative 35 you will have negative 8. So what kind of point is this? Exactly. So this point is the IP, inflection point. We have all the information we need. Of course, we should talk a little bit about symmetry, but this function is not symmetric. Of course, it's polynomial. It will not have any asymptotes. It's defined everywhere. All I need now is the chart. Ready? Here it is. Let's plot all these points. I'm going to say that this is roughly negative 2. So it's right here. Then negative 119. Oops. I'm going to have to create another and better coordinate system for this. Plan better. Plan ahead better. Okay, so I also have negative 35, so positive 19. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 10, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20. Okay. And then I need 35. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5. Okay, I think I'm ready now. So first, I will plot the points. Negative, so 1, 2. I'm going to say it's here. Negative 1 with positive 19. And 0, 5. 1, 2, 3, 4, 5. And then 0.2, 0. Tough. And then, okay, so we'll see what I can do here. And 2, negative 35. That's a tough one. And 2, 3.2 is 0. Ready? From negative infinity, increasing to this point of x-intercept, opening downward. Continues to open downward. It reaches a maximum at negative 119. And it continues to decrease now, still opening downward to the point, the next point of x-intercept, crossing at 0.5. Crossing here. Then it's continuing to the inflection point, which is 1/2 negative 8, where it no longer opens downward. It changes into opening upward, and it still continues to decrease to 2, negative 35. Continues to open upward, now forever increasing, crossing at 3.2 and going to infinity. This is the inflection point. This is the point of max. This is the point of min. Local max, local min. Any questions on this? Any questions? And no, we cannot determine the inflection point with the calculator. Okay, so we have about 8 more minutes. Can we choose a word problem, another word problem now?
53.
53. Very good. 53. I would have chosen the business marginal revenue, but that's fine. 53 is perfect. No. 53 is good. 289. Very good. So, in 53 it says, a ladder 25 feet long leans against a vertical wall. Okay. This is what I see. I see the wall, and I see the ladder, which is 25 feet. Good. Next. If the bottom moves away from the wall at the rate of 6 feet per second. So this point slides away at the rate of 6 feet per second. Okay. And I'll ask you in a moment what does that mean, but let's read on. So we have to write what this is in a minute. How fast is the height of the top? How fast is the height of the top changing? So this will slide down. And how fast is the top of the wall? What's the height of the top changing when the lower end is 7 feet from the wall? So here's what happens. Let's mimic this situation so we understand. So this is what happens. And at this instant, let's say, this point is 7 feet away. It continues to slide away from the wall, but I'm really interested to know the rate of change of this when this, at this moment, when the bottom is 7 feet away from the bottom of the wall. The bottom of the ladder from the bottom of the wall. So I need a ladder here. I'm going to say this is H. Initially, it's this. But then once the ladder moves away or slides away from the wall, then I hope you agree that this height becomes smaller. What are we asked to determine? So if this is H, I'm going to call this X. And we're going to read the problem one more time because we need to identify everything here. Number one, the ladder is 25 feet long. No one can change that. That's fixed. Leans against a vertical wall. Fine. If the bottom moves away from the wall at the rate of 6 feet per second, what is this?
Time.
Well,
It's,
it won't be per
distance
second.
over time. D
Correct.
over T.
The X over dt.
Dx over T.
Exactly. Indeed, it's dx over dt, right?
Mm-hmm.
Because that's the moment the ladder starts sliding away from the wall. Obviously, this is what changes, and it's a positive change, right? Because it's increasing. That's what it is. Perfect. Let's read on. How fast is the height of the top changing? So what am I asked to determine before I read on?
D
Over. Excellent. Do you expect this to be positive or negative? Remember, this slides away, X increases. But this comes down to the ground. So what about the sign of H? Right, I expect it to be negative. Keep that in mind. So we're asked one more time, how fast is the height of the top changing when the lower end is 7 feet away? This is the question. But remember, don't cross it out like that. I just want to make a point. At the very, very end, we cannot use that till the final step. Why? Because I have to have a function for h, and I have to find the h over dt, and then I plug in whatever. So, what can we work with here? I need a relationship between these two. I need a relationship between these two. It's a right triangle.
It's been a while.
That's okay. X squared plus h squared equals 25 squared. This is what it's called, the Pythagorean theorem, in which age and x are what?
Six
Functions
of time.
of time. Perfect. Let's differentiate. The left-hand side,
2x plus 2 plus times
yes.
x. Dx over dt. Sorry.
It's a function. That's what we just said. They're both functions of time. Plus 2h times,
dt over dt.
very good. And 25 squared or not, I don't care. When I differentiate it, I get 0, right? Any constant prime is 0. That's fine. So then dh over dt, remember I will also simplify by 2. I get
H.
negative x dx over dt divided by h. I moved x dx over dt to the other side and I divided by h. And now I have everything I need. When x equals 7 feet, dx over dt is given to us. It's 6 feet per second. The only thing I'm missing is h, but that's not a problem. I will move x squared and take the square root. So this will be 25 squared minus x squared. From the Pythagorean theorem, I solved for h. So I have this, which is 7, I have this, which is 6, and I have this, which is 25 squared, and I have this, which is 7 squared. I put all the numbers in, and I get, I know it's 8:15. If you just bear with me 1 second, or if you need to leave, you're more than welcome to. So I just want to punch in these numbers. Of course, as I expected, it's going to be a negative number. X was 7, and then multiplied by 6, and then divide by the square root
24.
in parentheses. Did you get that?
Yes.
24 squared and minus 49. Very good. So we got negative 1.75. Measurement unit, please.
Feet per second.
Feet per second. Because we are determining height. And as we expected, it is indeed negative.